Hello, statistics student. This video is for chapter 2.7, measure of spread and variation. We are going to calculate a number, which shows how data spread out and also how the degree of variation of data. So just a quick example. For example, if I have, let me get my pen ready. If I have some data like age, 18, like age of students, and then 25, 26, 25, 25, 26. So most of the students concentrate around this. And then there is a 40. So this is one data. And then I have 18, 19, 20, 25, 30. How many do I have? 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7. Let's say 35, 40. Okay, so in both sets of sample, this sample has a starting age of 18 and an ending age of 40. This one has a starting age of 18, ending age of 40. So if you just talk about spread, they have the same spread. But obviously, you can see that the first set of data are actually, except for the first and the last, they are all concentrated about 25, 26, very concentrated. Not that much variation, right? Except for the first two. Whereas for this one, they are evenly spread out. So from 18, 20, and then 25, 30. So in the middle, they are quite spread out. So if we just look at spread by looking at the range is what is the difference between the highest and the lowest? You would say that they have the same range, but the degree of spreadness is different, right? This is not very, but this is much more very. They spread out evenly, they spread out more. This is more concentrated. So we need a number that can show this kind of variness. You can say, well, Miss Chen, if I graph this in the histogram, this would correspond to something like very concentrated in one class, right? 25, 26. And then like maybe some days, well, actually, we only have one class. So it'll be one very big class that's all the data concentrated, and then some lower spread out so that the range is pretty much the same as for this one. You would see that the class are more or less the same, right? They have same number, you know, like that. So these are more spread out. This is very concentrated in a histogram. Now, the high bar means high frequency. So by just looking at the histogram, we can actually get a feeling that these are more concentrated, these are more varied, right? Data like differ from each other a lot. So how can we find a number that measure the degree of variness if the range from 18 to 40 are the same, right? They're actually big different. 18 to 40 are the same. So there's three numbers that can do that. The range is what we know. It only measures spread, doesn't measure degree of variness. And there's two other number that can kind of measure the degree of variness. The most important one is standard deviation. Is a term that is very important. It has a formula to calculate. And then interquartile range. I think you heard about interquartile range before when we use it to calculate outliers. But interquartile range is also a number that can calculate how data varies. Okay, so how do you calculate them? Range is, we talk about that, maximum minus minimum. Okay, remember it's not add, it's minus. So it just tells you what is the distance between the lowest and the highest. The properties of this measurement is not resistance, affected by extreme data, does not take every value into account, so and also doesn't measure the degree of rareness that much. It only concerns two data. The second one, which is I told you that the most important one, is standard deviation. Okay, so if you are to calculate standard deviation of a sample, the formula is like this. S is the square root of something. What is this something? First, you have each data value subtract the mean. This could be a sample mean, could be the population mean, and then square it. Square the distance how each data is away from the mean. Add all of this square distance together, and then divide it by n minus 1. Okay, so it is not the average of the sum of square, but divided by n minus 1 of the sum of square, and then take square root. So it's pretty complicated. And we don't divide by n minus 1 where n is a sample size. N minus 1 has a special name for it. It's called degree of freedom. So there is articles or there are numerous discussion on why we're dividing by n minus 1, but not n. It has to it has to do with the fact that if you know the first n minus 1 number, the last number is pretty much fixed and it doesn't have freedom. So that's why n minus 1 is a degree of freedom. It's kind of like difficult to understand, but you can Google and read about why they divide by n minus 1. So this is called the standard deviation. It tells you how each data are away from the mean. So on average, it tells you how data are spread out. Okay, so there's a lot of properties about S. And the symbol for the sample standard deviation is S. First, S is never negative because once you square a number and then square root, it's still positive. And when all the data values are the same, the mean is the same, then when you subtract from the mean, it's all zero. So zero means they don't vary. It's the same number. If you have a large value of S, that means the degree of variation is large. B is the fact that S is not resistant. That means if there is extreme value, one or more outliers, then S increased dramatically, substantially, just like the mean. The third one is S has the same unit as the original data. After you subtract X data value with the mean and you square it and then you square root it, the unit is the same. So if you're measuring money, standard deviation is also money. If you're measuring something like time, commute time, which is in terms of minutes, then S is also minutes. The fourth one, S is a bias estimator of population standard deviation. It does not center around the value of sigma. So we'll talk about more about these terms. There's a lot of like jargon, bias estimator. That means the more okay, so let's say if I know the population standard deviation, so I am ahead of myself. So sigma is this population standard deviation. So we know it is this one because we know that we have the population data. And if you use a lot of samples and calculate the S values, it turns out that it doesn't center around sigma. Okay, so we call it a bias estimator. E, compare standard deviation for data with similar mean only. So when we say, okay, large S is large variation, of course, if your mean is different, then you can't compare, right? So when you're comparing variation of data, make sure that the means are more or less the same, then you can compare variation. Okay, F, S increases when data are more spread out. So going back to the original example that we're talking about, if I calculate standard deviation for the first set, it will be lower because data are more concentrated. They don't vary that much. This too varies, but overall speaking, it doesn't vary as much as these. This particular data, if I calculate a standard deviation, it will be much larger than that one. So by looking at S, we can tell that, oh, this has a higher variation and this has a lower variation. Okay, so but we also want to make sure that the mean are around the same, so that the order of magnitude is around the same. We can compare standard deviation if one of them has a mean of 1, the other has the mean of 100, right? So it doesn't compare that way. The third measure of variation is IQR. So range dependent on or is affected by outliers or extreme data. IQR only measure the middle 50% range of data. So it's Q3 minus Q1. If this is big, that means data is more vary. If this is small, the data are less vary. So going back to the original example that we have, you can see if I get IQR, it would be like maybe from 20 to 35, so it's 15. whereas the IQR would be 1 right here, because the middle 50% of data is just 25, 26. So you can see IQR, ignore the outliers, and it's concentrate on the middle 50%. The idea is if the middle 50% of data are very concentrated, they are not as varied. So this would prevent the extreme data to go affect the variation number. So out of these three numbers, of course, the standard deviation is the most important one. So how do we find them? So so there's two calculator. One is the one variable statistic calculator that we have been using with mean. The other is statist that we have been using with mean also. So again, the same restriction. If your data is in a list form, use the one variable statistic calculator. If your data is in a column form, like in an Excel file or a Google Sheet file, then you use statist. Okay. If you want to convert a common list into a column, you can look at my video, another YouTube video that talks about that. So, but of course, you can also do it by hand. So the first example I'm going to do is doing it by hand. Okay. So I think mean, median, IQR are the most range, not mean. Range and IQR are easy to calculate, so I'm not going to calculate that. And I use a very small data. The data that I have has 4 number only, 15, 15, 17, 21. Okay, so I just want to find standard deviation. If you want to find range, range is what? The highest minus the lowest, right? 21 minus 15, that's 6. If you want to find IQR, what is the median? The median is 16, right? So we can find, we need Q3 minus Q1. So to find Q3, so we'll find the median first. Median is the middle mean, so it's 16. Q1 would be the middle of the first half. This 2, so would be 15. Q1 is 15. Q3 is the middle of the second half, which is the middle of 21 and 17. What is it? 21 plus 17 divided by 2. It's 19. So IQR is 4. So that's why Q3 minus Q1, IQR equal to 4. So you could do all this by hand, but standard deviation is more complex, even if you do it by hand. So let's look at the formula. Write the formula here again. So it is a square root of what? Sigma of each x minus x bar square over n minus 1. Okay, so let's look at how. So this is x 15, 15. I put it in a table 15, 15, 17, 21. And I add this together and I divide it by 4. So x bar would be equal to 17. We calculate by dividing this by 4. And then I would have each one minus 17. 15 minus 17 is negative 2. It's negative 2. 17 minus 17 is 0. 21 minus 17 is 4. And then I square it, right? So I did this. And then I square it. After I square it, I add them together. So this is adding the square number. And I divide it by not 4, but 4 minus 1 is 3. So I would have 30. 16 plus 6. 8 plus 16 is 24. 24 divided by 3 is 8. So square root 8 is 2.8. So that's how you do it by hand. To do it by calculator, so let's try. We can try this again. 15, 15, 17, 21 to show you how to use it. So I'm going to use the one variable calculator. Clean up everything first. What is it? 15, 15, 17, 21, right? You calculate. The standard deviation is 2.8, right? That's how you do it. IQR is 4, so that works. And if I want to do by statist, do I have time? Yes. I have time to do statist. So 15, 15, 17, 21. And then I do data, explore data, descriptive statistics, column 1, evaluate. The standard deviation is right here, 2.8. and the range 6 and oh, they don't